Good morning and good afternoon, everybody, and thanks for joining us for our next Build Your Simulation IQ session. Today, Todd and I are going to be talking about how to utilize the Decision Center, specifically focusing around CFD 2016. Just to quickly introduce myself, my name is John Wilde. I'm based in Brighton in the UK. It's a tiny little section right down the bottom on the coast, and it's always sunny. I've been using CFD now for, I guess, nearly 9 years. So I did about 4 years working as an application engineer and a consultant, and then I've done nearly 5 years supporting you guys, working with Autodesk.
All right, guys, I'm Todd Alford. I've been supporting CFD for about 7 years and done some extra work as consulting and training. I used to live up north in Cleveland, Ohio, and Rochester, New York. Moved south to get away from the winters, and now I'm back up in Boston area in the Waltham office. So apparently I'm a glutton for punishment in the winters and just don't want to get away. So today we're going to talk about utilizing the Decision Center. It's one of my favorite tools. It's something that I don't think enough people actually use the way that it was intended to be used. And hopefully this can get you guys excited to do a little bit more work in your designs.
Just before we get started, I mentioned at the beginning and at the end as well, there's a small link at the bottom, so at the end of the presentation we're going to upload this to Box if you do want to grab the presentation. We generally start, I guess, with a new section. I think we're going to stop doing that because we're kind of repeating the same thing to people that join us pretty regularly, but the content will still be there if anybody does want to refer to it.
Thanks, John.
So I guess today's discussion is really going to kind of be in 3 sections. So we're going to talk about what the Decision Center is and why we use it. This has been requested from a lot of users, and that's why we decided to talk about it today. Todd and I are then going to kind of split the different sections of the Decision Center into 2. So I guess I'm going to talk more about flow control and how we might look at measuring pressure drops and looking at flow through channels. And then Todd's going to use an electronics model to look at models where we might have some kind of thermal gradient or heat transfer taking place. And then he's also going to speak a little bit about what's new in 2016, so it's got a little bit more of a kind of focus around the Decision Center versus older versions of the software. So starting off, I guess, just talking about what the Decision Center is. Like Todd said, it's great, it's really powerful, and it's really a way to make side-by-side comparisons between either different designs, so we might have different, like a valve with different positions in CAD, or entirely different designs in CAD, where we want to compare results between them. And we can also run different scenarios within CFD, so we might have different operating pressures, operating flow rates, different ambient temperatures, for instance. So this graph, which we're going to show again a little later in context, just out of context right now, I guess it's just a pressure drop for a system. And there's lots of different designs and scenarios muddled up here, but the important fact is that we can capture everything and we can see all of the different designs and scenarios in one little screenshot, and we can from this make some really quick design decisions, so we can see which has the lowest pressure drop, which is the most efficient, which might have kind of kinks in it, that has pressure spikes, for instance. So it's a nice tool to get a kind of global view of all the different designs that we might be choosing before we figure out which one we want to move forward with.
Hey, John, can I kick off oh, this is my slide, so I can definitely kick off a poll. So I wanted to see how much you guys use the Decision Center. So I'm going to kick off a poll real quick and give you guys a few minutes to answer the poll and give us all a little bit better idea of how often it's getting used. All right, we've still got some votes coming in. We're up at 70%. All right, I will give you guys another 15 seconds or so here, and then I'll close out the poll. We're getting up to 3/4 of you guys have answered us. And then I will share those results back with you.
Todd, these results are reducing my skepticism in us talking about this. I don't know. The decision center to me is like a really common feature that I use all the time. And I know lots of users ask for it, but I kind of thought everybody would already know what it was. But looking at the polls, it's pretty useful. I'm glad we're doing it.
Yeah, no, this is fantastic. I know it's not utilized as well. Just to show you guys what we had for the polls, apparently about 42% of people, they don't even know what the decision center is. So that's fantastic. I'm glad you guys came to join us, and hopefully you walk out of here feeling like you're going to be a monster in engineering. All right, so let's go back over to the I can hide that poll. So all right, knowing that you guys are a bunch of people are just learning about it, more reasons to use the decision center. Again, I think it's the most powerful thing in there. Everything that you input into the decision center, starting with version 2015, there was a report generator, and when you generate that report, it takes all of the summary items that we have in the decision center and puts them into a Word document. So if you have everything captured, all of your specifications and your highlights of your design, you generate that report. Now you don't have to bring up CFD and dig through a model to grab stuff again. You can open that Word document and send it over to people. I mean, you saw my picture in the opening there. I need all the help I can looking good, and the Decision Center is a great way to do it. Another thing that we've always tried to harp on is design instead of verify. So you can make the best design by doing all your prototyping ahead of time as a simulation instead of spending the money to break ground and do everything ahead of time. So the model I'm going to show you guys is actually something physical that Autodesk makes. It's our 3D printer, the Ember. And I'll talk a little bit more about it later. But I'll hand it back over to John, I believe.
Yep, so you and I, Todd.
Right. Making sure this one wasn't my slide. I forgot.
No, you're totally fine. Okay, so just taking a tiny step back, just to speak a little bit, I guess, about how this works. So the Decision Center, like I said before, is going to help us either compare different designs side by side. So these are going to be they're going to be changes within our CAD model. We might have run an analysis and found out a region that we're not happy with. Maybe there's a massive pressure drop we want to get around, or a hot spot in the model that we want to improve the airflow over. So we might go back to CAD, make a change, and then launch our model back into CFD. And what will happen is that CFD will copy over the setup that we had before, so we won't need to repeat the setup and apply the boundary conditions and materials and everything that we had before. There's a little tip here, I guess, just to be a little bit kind of mindful when you're doing that. So CFD, when it assigns boundary conditions, uses surface IDs from CAD, and if you remove parts and add parts in, you can change what these IDs are, so the boundary conditions can move. It's pretty rare, but it's just something to be aware of, just to be a little bit mindful when you relaunch back in. So that's designs, and you can see on the bottom right there we've got an open and a close valve. So they're my two different kind of changes that I've made within Inventor, and within each of those I've got 3 different scenarios. So I've got 5 meters a second and 10 meters a second, so I've got different flow rates running through my unit, and then I've got a refined mesh as well. So what I've done is kind of compare different flow rates and different meshes through different designs to help me kind of decide or understand, I guess, what's happening through the system. So just to explain a little bit more about what we're going to do. So this is my valve. The image on the top is with it open. The image on the bottom is with it more closed. We know we've got a supply pressure, and what we want find out is if that pressure is enough to drive the flow through the model. And I'm going to really focus on summary planes and summary plots, and I'm going to look at some images, like an image comparison like we got here as well. And then Todd is going to look at the electronics model to cover some different points. But I guess planes and plots are like really useful for flow control. So before we jump into CFD, just to kind of give you an idea of what we're going to look at before I show you how to set it up. If we take a look on the left-hand side, there's a plane that I've got at the inlet of my model. And so I've got a flow rate on the inlet and a pressure on the outlet, it's boundary conditions, and I've got a plane right here, and I'm basically asking CFD to give me the pressure across that plane throughout all of my different designs versus a reference pressure. So that's my pressure that I've got as a supply. So we can then see if designs are beneath that, we know that they're going to run okay. If they're above that, we know that our design is too restrictive to the flow and we're not going to get the flow rate that we need based on the inlet pressure that we have. So just to kind of show you how to do that, this is my model. I've got flow entering on the left, exiting on the right. And all I'm going to do is add a cut plane to the inlet just down here. And then we can make it a summary. So if I click on Make Summary, that makes that a summary plane. And that plane then is applied to every single scenario that I have. And I guess I kind of work in an old school way. So Todd's going to show you the Decision Center thumbnail up here. But for some reason, I've kind of stuck with the old method of just pressing the space bar. And that flicks through the different options and it brings up the Decision Center on the left-hand side. If you see any exclamation marks on any of these items, it means that the plane has moved or the plane is new, and the results at the moment only apply to this one scenario. So we can right-click on it and update the values. I'll just do that again so you can see update summary values. So what CFD will then do is go into every single scenario and design that I have, and it will capture all of the different variables that I may need over that cut plane. So here it's showing me pressure. So it's giving me the pressure in whatever unit I choose. Here it's pascals because that's my reference as well across all of the different designs. And I can say select a row and press plot selected rows. And here I've got an understanding, I guess, of what my static pressure is going to be at the inlet. So this is the pressure drop that I'll have through my system with the flow rate that I've applied versus my reference, of course. So I've got like 3 conditions that are okay. But if I have a nearly closed valve with 10 meters a second, I actually need a higher pressure to drive the flow through the model than I have. So that design is essentially a failure.
John, can you point out where the that reference is put in a little bit closer? This is something I don't think a lot of people know about, because every time I see people in the Decision Center, there's never a reference put in. And that's like a specification that we may have been given. We know that we can't exceed this pressure, we can't exceed this temperature, something like that.
Yeah, absolutely, Todd. That's a good point. So just on the right-hand side here, under reference, we can enter our value here, and this is going to be our horizontal line across the graph. So I guess you'll be able to do the same with the Ember model. So when you've got critical components, you can set like a maximum temperature, right?
Yeah.
Okay, perfect. What I also want to do at this point, I guess, is just to show you how, if we find out we want to change something in the model, how we go about doing that. So, what I want to do is have not an open valve or a closed valve, but I guess one slightly in the middle. But how am I going to kind of do that in CFD and then relaunch my model from Inventor? So the process for that is pretty simple. I'm just going to right-click on my valve and clone it. So I'm going to have a nearly open valve. And what you see in CFD is that I've now got open, closed, and a nearly open with my different scenarios sitting within it. At the moment, this is an exact replica of the open valve. But what I can do is go back to Inventor. I've already moved the valve, so I can relaunch back into CFD 2016. And instead of, I guess, doing what most people do, just press launch, this time I'm going to move across to Update Design Study. And it gives me a list of all the different studies that I've run recently. And what I'm going to do is pick my new design, so my nearly open valve, and I'm going to press Update Design. And this will then push the new geometry into the already existing scenarios within CFD, and all of the previous information will be copied over. So now I've got my new design in my new position in CFD, and I've got my water, my aluminium and my steel, and my boundary conditions and flow rates and everything set up and ready to go. So now I could just run this, and if I had SimFlex, I could run them all in parallel on the cloud as well, and then I've got pretty immediate results.
One caveat there is when we're adding and removing parts, sometimes we'll lose or misplace boundary conditions. So always make sure that you verify that everything got set up exactly as it should be. Luckily, we still have jobs, and machines haven't taken over the world, so we have to make sure that we're asking the software to do exactly what we had intended.
Perfect. Good point, Todd.
Yeah.
Okay, so that kind of explains how we use planes and summary planes. But what is also really useful is a summary plot. So these are, I guess, like a graph along a cut plane through the model. What I'm showing here is just the pressure through the model as it changes and it passes through the small gap in the valve, and we can see all of the different designs side by side, so we can get a really quick idea of where the biggest pressure drop is, what the inlet pressure is, and hopefully the outlet pressure is the 0 that I've assigned. So it gives us a really kind of quick snapshot into what's going on. And just to show you how we do that in CFD, I'll switch back. So I've got a cut plane at the moment in CFD. I'd also just add that these axes sometimes get in the way of images, and it's totally okay just to drag them off of the screen over here to the left or right, and we can still use them and move the cut plane, but if we want to capture a nice image, they're out of the way. So I'm just going to turn off the vectors and make this shaded, and if I wanted to then do a plot through the model, I could. So I'm just going to add a few points real quick and then press plot. So the standard way of creating a plot is totally okay. Nothing changes, but all we do is tick summary, and then this is then applied to all of the different designs. So if I do my spacebar trick again and bring up my summary plots in the decision center, I can select my plot, which initially always appears really small and useful. I normally need to extend it out, and it's super cool. And then we've got a nice plot. So this is the plot that I created, and we can kind of see, exactly what we had before. But this is all of the designs compared side by side, pretty much instantly. Like you said, Todd, it's a great tool. It's really useful.
Oh.
And I guess finally, just to quickly look at images. I mean, if we wanted to look at, I'm just going to switch this back to showing vectors, so we can take a quick look at vectors through a small gap. So say we wanted to look at vectors through the small gap here, so comparing between the open valve and the closed valve. We could do that nice and easily and graphically just by creating a summary image. So I press summary image, and you'll see that image 1 appears down here. I can rename it. So I'll call it vectors through gap, and I then update the image. And what CFD will do is go into every single scenario once more, and it will apply this image to all of them. I can change my viewport settings. So I go to view and viewports, and I can compare two different views side by side. So on my left hand side I could have my open valve, and on my right hand side my closed valve. And if I change the view, they'll both move together. So I can very quickly get an understanding of what the flow rate is. The scales match always, so I can see on the right hand side my flow is pretty fast, as we'd expect. It's a smaller gap, and we can see there's a quick comparison between the left and right. Does that make sense, Todd? Do you think I left anything out?
No, I think that's good.
Okie dokie. So I think that covers everything I wanted to share. So I guess what I'll do is hand over to you so you can start to talk about electronics.
And toss me the ball. And while that's going on, we prepared another poll for you guys. So I'll kick off this poll.
This, I guess, is where you can be really kind to me, because I'm pretty much the only one that's presented so far. Or not, just be honest.
But yeah, I mean, we definitely want to judge as best how much information we need to get you guys, or if we're overdoing it. This is for you guys, and we want to be as respectful as we can about your time. All right, poll going for almost a minute here, so I will close this out. And I'll share the results back with you guys. For the most part, I think a lot of people are doing well, but a couple of people are thinking we're going through things a little bit too trivially. And maybe I should have done a better job in the beginning to say that this is really just an intro to it all and not a super deep dive of everything that we're doing. So I'll count that as a beating on me and not on John.
We can probably also say that 93% of people say this is either great or you'd like a bit more detail. So that, to me, seems positive, and I can still sleep tonight. But I guess the important thing it raises is, if you'd like more detail, please ask in the questions, and after Todd's covered his section, we can go into more detail if you'd like it. That's totally fine. Okay, Todd.
Yeah, I am not sharing my screen yet, right?
You should be. You have to end the poll, then you will be.
Oh, I didn't hide it. Sorry about that. And I will. All right. You guys see my screen?
Yep, that's good.
Perfect. All right. So I wanted to go a little bit into the summary parts and summary points. Super useful for thermal models, but they can be used in flow models as well. At least the points. Summary parts I don't think do quite as much when we're looking at just a flow-only model. But again, I think these are really powerful, and if people aren't using them, they really should. Let me, at that point, I'll hop over and give you guys a little bit of in-product demonstration. So summary parts. Again, this is a 3D printer from Autodesk. It's what I had shown there. I wouldn't have run this model the way that, with all of these things in there, like we had the whole housing, but it's more of part of a marketing ploy as well. So the whole thing had to be in, but we've suppressed a lot of it, and really we're looking at the electronics. So we want to see how cold, or if we're effectively cooling this thing. For making summary parts, we're just selecting the part, and we can either make it summary here, or we have that same kind of make summary out in the ribbon. Initially, I don't think in previous versions we had the make summary out in the ribbon, and this was the only thing, so I think a lot of people had missed it. And for people that don't know what a summary part will do, or what any, even if you're just in the parts dialog, you're grabbing the temperatures from some main types of parts, but if you actually grab a CTM or something like that, it'll give you all of the different operating points that you would get if you were just doing the hover over in the global results, and it brings up that little box. I can't do calculate and do these things live on this model because of how large it is. It takes a little bit of time to bring up. The other thing I did want to show you guys, since I have that, bring up that dialog. So when I'm looking at my summary parts, you can change your names in here so that, it's the second time that thing did that. You can either change your name or you can hit the reassign. Let's see if it'll let me do that. Because when you change your model, and it's not letting me select which part I'm reassigning. Well, this may be something that it's actually giving me the whole list. It's hard for me to click on. I don't know if this is happening because of the GoToWebinar, but I can select a different volume. Because when you do that updating process, if we've really changed the geometry, you'll see that your summary part is actually two different parts, and you could, that's something that you really need to verify and reassign the part to be the exact same part in both of your scenarios. That's something that happens a lot in electronics models, so I wanted to make sure that I pointed that out. Most people aren't doing the simple models that we usually show. You guys have products that are much more complex. So for summary points, quick tip of how I've learned to put these in is to actually use the view cube so that you get a good view of the model. And then, everything's going to start at the origin. And you can either slide using the different axes, and then if you're spinning the model around, you can find, just so that we can get it exactly to the part that we want. And then you're just creating a point, and then you can make it into a summary point. This one's much better labeled than what we have for the what we had for the wall calculator, where it was just a checkbox. So here to show you guys, really what we're outputting, it's going to be the same type of information where you have, I want to know what each different part is, and I can get their operating temperatures. So, did I not have? I thought I had a CTM in here selected so that you guys could see the different things that it'll bring in, because there it'll show your junction temperature, your case temperature, and your board temperature instead of just min, max, and average. And you can always select these and change them. Maybe that's only when I'm in the other view. But you can change your units. You have the ability to put in references. And here as we're looking at my models, something went real screwy, and that's probably because I was clicking around and changed a few of these parts. But I know when I was looking at a couple of them, I had dropped the temperature. Basically, I made it a forced flow instead of having it driven by natural convection. When we had it based on natural convection, I had really high temperatures that really were probably going to be problematic if I'm breaking 100 C. And I dropped those all to within an operating temperature that would be acceptable. Points can do the same thing. Here it's more of like a pressure transducer as well, because I can get velocities if it's out in space. If it's hidden within a solid, then I won't get any velocity or pressure really. All of your units can be changed, and references as well. So, and these can again all be plotted. Selecting and plot. Of course, I picked one that was 0 because I'm smart like that.
So it's similar to before, right? But instead of being like an average over an area on a plane, if you select the line and just do plot selected rows, it'll do that single one, Todd.
Right.
I don't know if that's easier. So yeah, I mean, we can actually kind of be very specific, right, and put like a point in the center of a part that we really care about, something, a critical component, and kind of get more specific than just like an average over an area, which is really neat.
So I wanted to also, and thanks for tossing that in, John. Appreciate it. Other thing I really wanted to make sure that I hit up, because I didn't know, how many people are still working in 2015 versus 2016. John showed you the updating by doing right-clicking. In 2016, we have this whole little ribbon interface that I find kind of nice. All of these clicks were available. So you could have done all of this in 2015, but it was more of a hidden right-click here, right-click there. We didn't have anything up in the ribbon, and it's just a lot easier to click this big button that says Update All or Select Scenarios, because maybe you only want to look at when the valve is open to compare it versus when the valve is closed, because you're having such a wide range in your values. Some of those things, I think, you can do it all in 2015, but you have to click around a little bit more. It's not as in your face. I thought that was worth mentioning. So if you're on 2015, it may get a little bit easier for you to use the Decision Center, because we've given its own section in the ribbon. And again, in 2015, it did have a spot in the ribbon to bring it up next to the report generator, but that's all that was in there. And I'll bring you guys over. So additional resources, look into the help and look at summary items. If you think there's something missing and we need to know about it, let us put in ideas in the idea station. I promise they're actually looked at by our development guys, and they look at, oh yeah, we really should have that in there. That would be a big help to a lot of people. Work with the community in the forums. John and I are in there and checking things out as well, so we can always help you out. Reach out to us before frustration sets in. John just wants you to get there before his baby wakes him up in the morning, and then he's all about helping. And again, you can grab this slide deck.
No, that's not what I meant.
What's that?
That's not quite what I meant. You don't have to get me up before 5
You didn't want them to wake you up instead of the baby?
If my baby happens to sleep in past 5 or 6 a.m., then yeah, I might be helping you guys beforehand.
Fair enough. But yeah, this slide deck's available. You can grab it and definitely reach out to us. I appreciate everybody's time for coming to join us here, and yeah, we'll go and try and address some questions here. And we'll probably wrap this up in about 10 minutes and give you guys an extra 20 minutes back to your day. So, John, have you looked at any of the questions?
Yeah, there's just one, but I wanted just to talk about one thing that I think you can do on your screen. So if you, I guess, like you've got a thumbnail there, right? So you can switch really easily between points and parts. And also summary images, and you can kind of have thumbnails of all the different images along the bottom. I can do it on my screen, by the way, if you want me to.
So you're just saying use these the tabs here?
Yes, it's just kind of nice. It seems like it has everything in the view, and if you click on split views at the top and like show an image, and then click on one of
my images aren't coming across for some reason.
Okay.
I don't know. This is a big model.
Just click on the summary images thumbnail right on the bottom for a second. Or I can show on my screen, so I've got a few and it looks fine. Let me do that.
Pass the ball back to you.
Yeah, no worries. And we've only got one question right now about Fusion, and I'm not sure exactly what archives are within Fusion.
Check the question.
So as far as I know, there's no reason why we couldn't use Fusion 360 to add loads of different geometries to CFD. That should be totally fine. Yeah.
And just to add on to that, the Sim Studio Tools is kind of the same. It's the same platform, so everything will feel the same, but it's on your desktop instead of Fusion 360 being kind of you're working and manipulating everything in the cloud. Just Extra FYI.
Can you still hear me okay, Todd?
Yes.
Okay, so my kind of meeting dashboard is totally greyed out. So I can't share my screen, and I can't do anything. I can't mute myself, but I can talk. So you might have to let me know if any questions come in, and I can definitely contribute, but short of leaving and coming back in, I can't do a lot else.
Okay, I will take the presentation back over.
Cool.
Sorry,
Thanks.
Sorry we couldn't share an image better. I guess I could try and grab one.
I guess all you kind of need to do to show the idea is to click on the summary images thumbnail, and you'll still have the different thumbnails of all the different images. But I guess there'll just be loads of grey boxes, but it kind of shows that it's really super easy. It's annoying that I can't show my screen, but you can really quickly click on any thumbnail, and it shows all the different images from any different kind of snapshot that you happen to have taken.
So you're talking about these guys?
I don't know.
Oh, you can't see it all either. I do think I know what you're talking about, so I clicked over to where it has the thumbnails down in the bottom left. Let me take a quick look at what our questions are. I'm not sure. I mean, as long as you've ran the models, the tricky thing is you want to actually create them in the same design study, if I actually understand that question properly. If I'm not getting that, then definitely reach out to us and we can answer that in a case.
What was the question, Todd?
The question is, it was the one that you were talking about, can I add the results from different archives to the Decision Center? It actually has to be in the same design study file. That's what I take away from that question. It's the Autodesk CFD license. Is the license for Autodesk CFD separate license, or is it part of the Autodesk package? CFD is its own license. The Decision Center is just a part of CFD. It doesn't require an extra license or anything like that. That's available for everybody to use.
So there are a couple of different licenses, right, for CFD. So there's the interface, which is everything that you see here, and it includes the Decision Center. There's CAD connections. I guess most people here are probably using Inventor, so you don't need a CAD connection. And then there's different solvers as well for different kind of levels of kind of physics within CFD. But yeah, like Todd said, the interface includes this Decision Center. It's all just as it is.
Yeah, and if you're using the 360 version for the cloud, that comes with all of it as well.
Yep.
So we're coming to the end here, and I haven't seen anything else come in. It looks like Peter wants to have a chat, and we'll create a case and reach out to you.
Perfect.
But on that note, everybody have a good rest of your day. Good evenings if you're heading home. And again, thank you for joining us.
Yeah, this was useful. Thank you, guys and girls.